Welcome back to Mbakwa Phosphate Academy. Today we will be looking at chemistry. Welcome to Mbakwa Phosphate Academy of Science and Technology. I am your brother Mbakwa Phosphate, as students popularly call me. I am your tutor in chemistry. I have come to teach you chemistry. I believe you are going to enjoy this lesson. If you do enjoy the lesson, don't hesitate subscribing to our channel. Contact us at 679953185. You can write us at mbakwaphosphate@gmail.com. We have a Facebook page, Mbakwa Phosphate Academy. Just click on your Facebook page. You're going to see that page. Matter. I've come to teach you matter. You must have been hearing about matter in sciences. We hear about matter in biology, about matter in physics, chemistry. What is matter? Matter is anything that occupies space and has mass. The space occupied by matter is called volume. So if I have a book as such, I can calculate the volume of this book. Now, where the book is in my hand. I cannot put this phone on the very place where the book is, because the book is occupying a certain volume. So matter is anything that occupies space and has mass. The space that matter occupies is called volume. Now, the mass of matter, be it liquid, solid or gas, as we saw in our last video, so that matter could be solid, could be liquid, and it could be a gas. So the mass of matter, be it liquid, solid or gas, can be measured using a balance. Now I can simply turn here and I have a balance. This is a scale balance. Here it is. You can use this scale balance to measure the mass of matter. The volume of matter can be measured using a measuring cylinder. You must have seen a measuring cylinder in my last video, where I was introducing you to the laboratory. If you have not watched that video, just go ahead and see the other video. You see a measuring cylinder. That's to get the volume of liquid. We simply use a measuring cylinder and we get the volume of liquid. But we could also use other graduated instruments. Matter can be described both by its physical and chemical properties. The physical properties include hardness. The physical properties of matter include hardness, is the matter hard? We also talk about the texture. Talk about the color of the matter, talk about the density. Remember, density is raw and is given by mass over volume. We also look at the ability to dissolve in water or other solvent. You know, there are matter like kerosene that will not dissolve in water. Now we can talk also about the chemical properties. Chemical properties. The chemical properties of matter. So chemical properties include matter's ability to change into different substances. There's a possibility for matter to be converted to different substances. So substance can exist as either solid, liquid or gases. So matter can exist as solid, liquid or gases. These are the three states of matter. Anywhere you hear about the three states of matter, you will say matter can exist as solid, liquid or gases. You are not wrong. The state of matter: solid, liquid, gas. Just look at the solid, look at the liquid, and look at the gas. What can you say about their structure? State of matter. When we look at milk, cock, bell, what is different? Milk is liquid, cock is liquid, bell, oh, solid, hard, touch it. Book, solid, pear, oh, it's solid. Hot air balloon, wow, hot air balloon, that's gaseous. Pen is solid, yeah, using a pen here. Balloon is a gas. What is inside this balloon inflated is a gas. So you see the state of matter, it could be solid, liquid or gas. Wow. Now you see that through melting, you can take a solid to a liquid. You can take a liquid to a gas through evaporation. You can take a gas to plasma through ionization. You are going to know this when you go to higher level with biology. You will know that carbon dioxide dissolves in blood to form what we call oxyhemoglobin. That is during the process of inhalation. The oxygen gas in the atmosphere will be sent to the lungs. And you know there are some red pigment in blood. We call it hemoglobin. The hemoglobin will have high affinity for oxygen, so it's going to attract oxygen. When it does that, what is formed is called oxyhemoglobin. That is how oxygen enters the blood. And you know oxygen is needed for tissue respiration. Let us not go into details of this biology, but you see that for gas to go to plasma is by ionization. You see here, the arrow shows adding energy. You can add heat to a solid, the solid is going to melt. You can take, for example, a piece of ice, or you take ice from the fridge, it's solid. When you keep it outside, it begins to melt into liquid. When you heat it, it evaporates into gas. That is what we call change of state of matter. Change of state of matter. Now, is there a possibility to take back the gas back to the liquid? Yes. We are coming to see that the process is called condensation. You can condense back the gas to liquid. You can condense back the gas to liquid. Now, is it possible that you have back the liquid in a glass? What happens if you take it back to the deep freezer? Can you imagine that? After some few hours, you come back to meet liquid. Is that true? No, it's not true. You take back the liquid back to a deep freezer, coming back, you meet solid. What has happened? It is said that the liquid freezes back to solid. These are all change of state of matter. Remember, you are working with Backward Phosphate Academy, and I teach chemistry and call Backward Phosphate. Matter that make up the universe exists in three different physical states, namely the solid state, the liquid state, and the gaseous state. Here we are. We have the solid. You see the molecule held in fixed pattern but vibrating. The molecule in the solid, they are held in fixed pattern but they are seen to be vibrating about their mean position. Particles move forward, move backward, move up, move down. That's exactly what is happening. So in the solid, the particles are vibrating at their mean position. What happens for a solid to go to a liquid, like we said? We said that there is melting, or what we call liquefying, become a liquid by liquefying. You can equally change a liquid back to solid by freezing or solidifying. You are becoming a solid, so we say it's solidifying. Now look at the molecules in the liquid. How are they arranged? Molecules packed close together in a random fashion, free to move. So in the liquid, the molecules are free to move. They move about each other, touching each other. That's exactly what happened in a glass of water. Molecules are free to move. But in the solid state, the particles are not free to move. What can you say about the force of attraction in the solid? So one can begin to conclude that the force of attraction keeping the solid particles together, they are stronger than what we will see in the liquid. So the force of attraction in the solid state is stronger than what we are going to see in the liquid state. Because in the liquid state, though the particles are still held by some weak forces, we are coming to see that those forces are called intermolecular forces. We'll start hearing about Van der Waals force of attraction, hydrogen bonding, dipole-dipole attractive forces, or what we call the London force, Van der Waals force of attraction. Here about London forces, but that's not what we are very interested with now. We are interested with the forces, the force of attraction keeping the liquid particles or molecules together. And we say that they are weaker as compared to the solid. Can we change a liquid to gas? Yes. Boiling, vaporizing, or evaporating, or what we call evaporation. See the gas. Interesting. We can condense back. Imagine you are cooking fufu corn, or you are cooking rice, and there's a lid of the pot. When you remove the lid of that pot, do you just turn it into your mouth? Answer is no. You can't do that, because you have water vapor that is now stopped by the lid of that container, and the water vapor, of course, is very hot. So that's why you always remove the lid of that container and turn the container beside. You see some droplet which is very hot. Imagine that you were heating the water and remove the heat. Allow the water to cool down. You will observe that if you were in a transparent container, the vapor that was on the lid of the container will have to condense back. That process is called condensing or condensation, or what we call liquefying. Now, what about the force of attraction in the gas molecule? Little or no force of attraction exists in the gas molecule. The gas molecules, widely separated, move at great speed. They move at great speed. So they do not have any force of attraction. That's why when you mess the air at one corner of your house, your sister, your brother sent at the other end, because the molecules or the particles have little or no force of attraction holding them together. Can you imagine? There's a process. Solid going to gas, skipping the liquid state, move directly from solid to gas. This process is called sublimation. Subliming, or what we call sublimation. We are going to see this in our next lesson. We'll see substances that will sublime. Examples include iodine, dry ice, ammonium chloride, camphor. I think camphor is common. When you take camphor and put in the box of your dresses, or coming there you don't see any liquid, but before you open the box of the dress, somebody get the scent. What is happening? Camphor changes state directly from solid to gas. That process is called sublimation. So you see solid state. We want to look at the solid state. And we see that matter in the solid state has the following properties. 1. A definite shape. 2. A definite volume. 3. Incompressible. Let me see a solid. This is my phone. You see, it has a definite shape. You can see the phone is rectangular in shape. Length times the width. If I want to get the volume, I take the length times the width times the height. Yeah, that is the volume of this solid. It has a definite shape, definite volume, and of course, can I compress? No, I can't do that. Difficult to compress. This is an example of a solid. You can see my writing pad. It's a solid, almost a square. But I still see more of rectangular, difficult to compress. Some examples of substances in the solid state include, you have charcoal, ice, iron, aluminium, yellow stone or sulfur. Those are examples of substances in the solid state. We want to look at the liquid state. Matter in the liquid state have the following properties. Liquid do not have a definite shape. So what happens? They flew to assume the shape of the containing vessel as illustrated with the various liquids. So liquid have a definite volume, not a definite shape. Liquid do not have a definite shape. So they will only flow to assume the shape of the containing vessel as illustrated with the various liquids. So liquid have a definite volume. Can you see that? Look at the liquid. It can only take the volume of this container. So it flew to occupy the volume. We also see that liquids are incompressible. You can't compress liquid. Example of liquid we are talking about is water, kerosene, petrol, mercury, alcohol. These are examples of liquids. You cannot compress liquid. How is that demonstrated? Wow, can you see something? You have a syringe. I have taken some liquid in the syringe. Can you compress the liquid? No. Difficult. Try that. Block one end of this syringe here. Block it there. You see? Block this end here. Like this. And then you see. You try to compress the liquid. The liquid will say, no, no, you can't compress me. Interesting. So you cannot compress a liquid. So we say liquids are incompressible. We want to go to the gaseous state. Can you watch for yourself? Gases have the following properties. They have no definite shape. So when you have a gas in the container and you open the container, you can see something here. The gas flows, has no definite shape. They have no definite volume. They always occupy any container in which they are put. Any container you put the gas there, it will occupy it. Gases are compressible. You can compress gases. Imagine the balloon we see at the beginning of this lesson. You can actually compress the balloon. So you are compressing the air inside the balloon. I will say that example of gases, we have oxygen, nitrogen, carbon dioxide, water vapor. These are all components of air. Wow. Can you see something? You see, we are able to compress this compression of a gas by applying pressure. It's a gas, you can apply pressure at one end here and the gas will be compressed. Gas can be compressed. Gas can be compressed. Look at something. I have a balloon here, connect it to this container of gas. What happens? Gas enters the balloon. You can compress the balloon. You can compress this balloon. So the air expands. Wow, it's interesting. This is an example of how gases move. Remember Brownian motion. They are in constant random haphazard motion. So they move randomly. Forward, backward, upward, any kind. Because they have very little or no force of attraction. This is what happens when you have heated air. The heated air will expand. Here, this particular, the heated air is going to expand. And this is how gases are going to behave. Thank you so much. Dear student, I am your chemistry teacher at Bakwa Phosphate Academy. Do not hesitate to ask any question where you have a doubt. I'm pleased you did enjoy the lesson. You reserve the right to subscribe to the channel. If you did, until next time, bye-bye for now.